Okay, so let's go through the second example. So again, whatever you do, you can save it to a packet.file, so save as. It'll be the default option, only option.packet, and type some name, and you just upload it to Canvas as part of the submission. So I'll be able to download it and test if everything is running. Okay, so that's how I plan to evaluate this. All right. So let's do the second example in the slide, which is this. So I want to create now 4 VLANs connected to 2 switches like this, and then they're in turn connected to a router. Okay, so let's set it up. So first click on the networking device, switch 2960. I want to create 2 switches. So let's create one switch here and another switch here. Then let me make sure it's recording. All right, so I want to create VLAN 1 and 2 on one side and 3 and 4 on the other side. So before we go through the process, let's come up with the IP addresses for these devices and the gateway routers based on the subnet addresses given to us. Uh, so here I change the subnet mask to 25. So that means the first 25 bits for the network plus subnet and the last 7 bits for the host part. Okay, so for VLAN 1, it is 192.168.10.0/25 is a subnet address. The host could have 192.168.10. Now, if you expand this out, it will be like 192.168.10 dot the 0, 0, 0, 0, 0, 0, right? That's what /25 means, where these 25 bits are for the network plus subnet, and these 7 bits are for the host part. So I can play with these 7 bits for the host part. So I can make this to be 10, because 10 would be, and let me copy this. 10 would be something like this one. This is 10, 8421, right? So that's 10 /25. That could be the IP address, host IP address. And then I can make 192.168.11, so 10.11/25. There's another IP address for a host. And the gateway IP address is the first, so as I said, the first available IP address in this range for this host part. The first available IP address is going to be if you put a 1 here. So those for the host. And gateway, you can say it's 192.168.10. So this is for the gateway. So for the gateway, we can make it 10.1/25. So I encourage to work it out like this so that things will be easier, so that you don't make any mistake in configuring the host IP addresses and the gateway IP addresses. Okay, so let's do that for all the 4 VLANs given to us in this topology. So that is easy to do then on the setting up process. So that's for VLAN 1. So VLAN 2, you're given the range to be 192.168.20.0/25. So that again means it is 192.168.20.0. That's the subnet part. Then 0, 0, 0, those 7 bits for the host part. So again, the gateway can be the first available IP address in this range. So the gateway can be 192.168.20.1, and the host would be 192.168.20.10. So now things will be easy to visualize and configure. Again, you could make 2, 3 to be the host IP address as well. It's up to you. So whatever number you want to choose, or you could even make say 70, 71 is entirely up to you. Okay. Anything within this range for the host part, other than the one to begin with, or all ones, because that will be then the broadcast IP address. So anything from say 2 to 126 should be good enough in this case. Okay, for the host IP addresses. So that's for VLAN 2. Now let's do VLAN 3. So VLAN 3 is here. Okay, so that is a little bit involved. So let's do it carefully. So VLAN 3, the subnet address is given to be 192.168.20.128/25. So that's the case. It will be 192.168.20. I know 128 is basically this, right? So this 128 for us. So this is going to be the network plus subnet part, and this will be the host part. So the gateway available address will be the first available address within the host part. So we can make this last bit to be 1 and combine this one with this 128, it will be 129. So the gateway IP address for this subnet will be 192.168.20.129. The subnet mask of 25, and the host could be 128 plus other than 1. So it could be 130 and 131 if you want to. So 192.168.130, sorry. I think that's what I have, 20.130. Let's make sure I have here. Yeah, 130 and 131. So 20.130/25, 192.168.20.131/25. That's for VLAN 3. Now for VLAN 4, it will be 192, given here as 192.168.10.128/25. So 192.168.10. This is 128/25. So we can again make something like this. So that's this 7 bits form the host part. So the first available IP address within this for the gateway will be 192.168.10. Then 129/25. And the host will have 192.168.10. Say 130 .130/25, 192.168.10.131/25. So once you have set up all this information in paper on a text file like this, we can go in and create the different VLANs. Okay, so let's do that now. So let's create the end device, the 2 computers here. Right, so let's create on this, click on this connection. First PC 0 to the switch, and again click on this, then PC 1 to the switch. So for VLAN 1, I have the host to be .10.10 and 10.11. So let's see, you can copy and paste it. That will make it even easier. So click on the thing, go to desktop, go to IP configuration, this. And the subnet mask will be by default a 24 subnet mask, 235.255.255.0, but you have to make it .128. So you have to make that change because you're having 25 here as a subnet mask. That will be in binary and like in the 32-bit format, 255.255.255.128. That's a subnet mask for 25 bits for the subnet host network and subnet, and really 7 bits for the host part. Now the gateway we narrowed down to 192.168.10.1. So that's fine. So that's for this PC. Then for this PC, IP configuration, I want to make it 11, and again 128 because for 25 that's a subnet mask number. And then this is 192.168.10.1. So let's do that here. And then you can also add a text indicating this is VLAN 1, 192.168.10.0/25 as a subnet mask. And the gateway, just for our reference, is 192.168.10.1/25, of course. Okay. So click on here to come out of this text window. Now you can leave this to be 1 and 2, right? So that's automatically VLAN 1, the switch. So let's go to end devices. Create these two PCs here, PC2 and PC3. Connect them to the switch. Okay, so let's set up their IP addresses. That's for VLAN 2. That's for VLAN 2, and the way I have it is I believe 20.0/25. If it is 20, this is then 20.1. So we'll make it 2010 and 2011. So 192.168.10. So 20.10, and we'll make it 128 here. This is 192.168.20.1. That's the gateway IP address. For this, it will be stop IP config 20.11. It will be 128 here. This will be 192.168.20.1. The gateway. All right, so this is 3 and 4, or 3 here, and this is interface 4. Now we also need to just leave it as it is. We don't need to connect the two switches in this setup, so that's fine. So let's set up the VLANs on this side. Click on the PC tab button right here. So this is going to be VLAN 3. Which is 10.128/25. That's a subnet address. So gateway was 129/25. So, and the IP address was 192. Of course, you can go back to that editor where I was typing all these things, 10.130, and make it again 128 for 25 bits for the network plus subnet. This is 192.168.10.129. That's the gateway IP address for this VLAN. And this will be the 131. So 192.168.10.131, 128, 192.168.10.129 for gateway IP address. Okay, so let's connect these two PCs to a switch. Okay. Then that will be interface 1 and 2 for the switch again. So let's do VLAN 4. That is similar to this one. VLAN 4, that is 20.128. And the gateway is 129. So let's create the two end devices. and connect them to the switch. Yep. Click on them. So this will be IP configuration 192.168.20.130. Make it 128 here, and this will be 192.168.20.129. That's the gateway IP address. And this will be here again 192.168.20.131. 128 here, and this is 192.168.20.129. That's the gateway IP address. All right, so we have 4 VLANs. So let's go and set up those VLANs in the switch. Click on the switch 0, go to config tab, click on the VLAN database. And so right now the switch has only VLAN 1 information. So let's add VLAN 2. The VLAN number is most important. The naming is just our convention, but let's be consistent. We just give the same name, VLAN 2. And then add VLAN 3. Because the switch should be able to carry traffic or forward traffic originating from different VLANs. So then VLAN 4. Okay, so do the same thing with the other switches. But before we also go to other switch, let's set up the well, we'll come back to that. So let's add the VLANs here. So click on the VLAN database. So 2, VLAN 2, add 3, VLAN 3, add 4, VLAN 4, add. Okay. So now we want to connect these 2 switches to a router because that's how we can forward traffic across the VLANs. We need a layer 3 device using a router. Let's use, we need only 2 interfaces again. So a 1941 model should be good enough. So click on this cable, auto cable, connect this switch to this router on this interface. So that will be G0/0. And again, click on this, connect to this router, switch to this interface, which will be Z0/1. So just move the cursor there. Don't need to click on the triangles. Okay, so now let's see. So this will be 0.5 interface of the switch. This will be also 0.5 interface for the switch. So you want to make these 4 interfaces to be access mode for the corresponding VLANs, and this should be in trunk mode, covering all the VLANs. So let's do that for this switch. So as you place the cursor here, you see interface 1 and 2, right? Interface 1 and 2 are in VLAN 1. So we can leave that to be as it is, VLAN 1. And interface 3, which is corresponding to this PC, and interface 4, which is corresponding to this PC, both are for VLAN 2. So these 2. So we can make interface 3 to be in VLAN 2 and interface 4 to be in VLAN 4. Sorry, VLAN 2. Interface 4 to be in VLAN 2. Now, all these 4 interfaces, you see now they go through this process of getting configured. All these interfaces will be access mode. All this is both are 1. This is 1, 2, 3, and 4. Everything will be in access mode. Now, interface 5 is the one that we connected to the router. We have to turn it to trunk mode so that it could carry traffic belonging to different VLANs. So close this tab. So again, click the switch. Now before that, make sure identify the interfaces. So if we go by order, so PC4, that's the first interface for the switch. PC5, the second interface for the switch. So interface 1 and 2 belong to VLAN 3. Then interface 3 and 4 belong to VLAN 4, right? So interface 3 and 4 belong to VLAN 4. Let me zoom in. So if you place the cursor there, you see interface 3 and interface 4, they belong to VLAN 4. And interface 1 and interface 2 belong to VLAN 3. Let's go back. Getting too small. All right. So let's go to the switch and configure that. 1 and 2 are in VLAN 3. So interface 1 and 2 are in VLAN 3. Let's click on this. Both are access. So 1 and 2 are in VLAN 3. Then 3 and 4 are in VLAN 4. Three and 4 are in VLAN 4. And this is interface 5 for the switch connected to the router. So interface 5 for the switch connected to the router will make it trunk mode. That means you can access all VLANs on this link. So close this tab. Now let's go to the router. So the router, put the config mode. Let's get the VLAN database. So it's by default only one is there. So VLAN 2, add it. Then 3, VLAN 3, add it. Then 4, VLAN 4, add it. Okay, so now let's go to the two interfaces. So this is G0/0, this is G0/1. So let's do G0/0. It needs to be configured with, because it's only one physical interface, but you have two VLANs. So we'll create two sub-interfaces on this G0/0 and assign the gateway IP addresses for those corresponding sub-interfaces. All right, so click on G0/0, make sure it is right away turned on, so you're enabling it right away, and click on the CLI tab. So that interface is up. So now we need to create the two sub-interfaces. For that, the command is, once you are in that interface, main interface 0/0, the create sub-interface int G0, that's always G0 slash 0 is the main physical interface number, 0 dot, we're going to be consistent with the VLAN number, so let's make it 0.1. And just press enter to turn it up. Then the next thing you have to write is encapsulation, not IP address, encapsulation. So .1q, both these are this fixed syntax. Encapsulation .1q. Okay, that's the syntax. And then the VLAN number is 1. And then the gateway IP address. So IP address 192 for the gateway, 192 dot for VLAN 1 it is 10.1. And then the subnet mask is 255.255.128, not 0, because you have 25 as a subnet mask number. Press enter and no shutdown. Okay, now let me just increase the font size a little bit to show this thing. So let's go back to the router. So we are again 0/0, click on the CLI window. So now I want to create that 0.2 sub interface. So int G0, that's always G0 slash. The main interface is 0 dot. The VLAN ID is 2, so let's use the same number. So it need not be, but let's follow the same for consistency. This is for VLAN 2 sub interface 0.2. Press enter. Then the first thing I do is encapsulation .1q. Then the VLAN number is 2. Then the gateway IP address is IP address 192.168.20.1. And then the subnet mask is this 128. Okay. Press enter and say no shutdown. So we're done with the two sub interfaces for this physical interface 0/0. So now let's do it for this one. So this is physical interface 0/1. So go to that, make sure the port status is on to make it on and running. So now we want to create two gateway IP addresses, one for each of the sub interfaces. So go to CLI window, press enter. So now we are at 0/1. So int g0 again slash now 1 because that's the physical interface number we are in. 1. See 0/1, 0/1 consistent. So dot. Then the sub interface number. So you can make it 3 corresponding to that VLAN ID. Enter. Press enter again to turn it up. Now let's do the encapsulation. Encapsulation dot 1q. Always the same, but now the VLAN ID here is 3. Enter that. Then IP address is for the gateway router 192.168.10.129. That's the IP address of the gateway router. And the subnet mask is 255.255.128. Then press no shutdown to make it on and running. And you can come back and go to create the next interface G0, but this will be 1.4 because the main interface is 1 dot, the sub interface has to be corresponding to the VLAN ID 4. Press enter. Encapsulation dot 1q4, then IP address 192.168.20.129, and then the subnet mask dot 129. Then let's see. So not 120, it should be 128, right? Yeah, 128 subnet mask. So the gateway IP address is dot 129 says bad mask. So that's right. So 20.129 is the IP address for the gateway router, and 128 is the subnet mask. So it should be fine. So you can say no shutdown and then exit. Or just clicking no, making no shutdown and just closing should be fine too. So everything is up and running because we turned the port status on, so you don't have to wait for the router to get set up after entering all these settings. So we make sure these two are in trunk mode for 5. Yes, in trunk, because that's important for these two switches to be in trunk mode, the connections to switch to the router. All right, I think everything is set up. Let's test the connections. Go to the PC, click command prompt, and let's ping one of these devices on the other side to check it's connecting to them. So 192.168.20.130. So probably the first one or two requests will time out for the ping. You should be able to get a reply right away. Okay. All right. So let's try this in simulation mode. So everything real time mode so far. Just click on simulation tab now. Edit filters. We don't want the unnecessary things. Let's enable only ARP and ICMP and disable these. Okay, now let's click on a packet. Let's see. Put it here as a sender and put it here as a destination. And click this triangle. So it tries to find the MAC address of this device. It's the ARP request to the switch. It first tries within the subnet or VLAN. This guy doesn't have that MAC address, so it's the router also. There's a broadcast within the domain. The router says now it knows that the device is the router got the MAC address of the device. I think. Let me check if it's doing a broadcast. You see also the message is being displayed. Yes, it is an ARP request. So the router sends it has to be broadcast to some other VLAN. So see now it's broadcast to this VLAN. So you see the name of the protocol going through. So this sends an ARP response to switch. The switch will send an ARP reply back to the router. The router will, you see what's going on here simultaneously. The router will then send back to the switch 0. This is some spanning tree protocol message coming up now. Because that's why in simulation mode, even though we disable behind the scenes, some protocols may be still running. So I think it's trying to configure the ports or something. Let's see. Still they're using STP protocol. I couldn't disable that one. Let's see. So we have a lot of things here. Oh, so we may have to disable it. But that might be needed to configure the switch ports for designated port and stuff like that. Yeah, so let's disable all of them, but it will take time. Let's try once. But I think STP is required to get to know the designated ports and stuff like that. So that's why simulation mode takes more time to really get things to see that they're happening. Okay. So let's turn off simulation mode. We're not going to do simulations. Just say real time. And let's say in real time, I want to ping from this PC2 to this guy here. So let's say I ping to 192.168.10.130. I'm getting the reply right away. So that's what real time. Okay. All right. So let's do one more ping. Say from this to something here, 20 dot ping 192.168 to 20 dot say 11. You should be able to do that. So first figures may time out because it's trying to find the MAC address, then you should be able to get the reply. So what happens in real time so quickly in simulation is taking so much time for all those different messages to go through. Okay, so you can delete this simulation, you don't need it. And so that's kind of how you do the second example in the slide to communicate now across VLANs connected to different switches and going through a router. Okay, so if you want now, we can add just one computer to one of these VLANs and see how we can go through the process. So click on end device, click on a PC. Let's say I add to this VLAN. So that's like we had already 10.130 and 131. This is 130. Place the cursor there. This will be 131, right? So let's make this 132. 132. So 192.168.10.132 with 128 as a subnet mask. And the gateway is 192.168.10.129 gateway IP address. Close it. Connect this PC to the, click on this here to make sure this appears on this screen here, this part here, and then, okay, click again. Only if it comes like you can drag it to the switch. So this is interface 6, and that has to be configured in this switch. Interface 6 has to be in VLAN. This is VLAN 3. So it's access mode, but this is VLAN 3. Okay. Let's do one more in some other VLAN. So let's say end device. So let's say we put it, click on the PC, put it out here. This is 20.10, 20.11. So you can make it 20.12. So this is IP configuration 192.168.20.12. Again, 128 is the subnet mask, and then 192.168.20.1 is the gateway IP address. Now this is connected to, didn't connect yet, so let's connect it. Click on this. Okay, so this is connected to interface 6 of this switch as well. So click on interface 6, it's access, but it belongs now to VLAN 2. Close it. So this PC is already connected to the switch successfully, so it will take some time for this kit to get connected. So let's test from this PC to something that's already there. So ping to 192.168, say to something here, so 10.10. You should be able to get the reply. Let's try with the one that we just connected to. That is 20.12. So remember, that's what I set up its IP address as. So it will time out just now because it just turned green. So first request may time out, then it will probably get the reply, or another request may time out too. Yes, now it's getting the reply. So everything is fine. So let's now try from this PC. Something over here, ping 192.168.20.say 130. It's getting a reply from there as well. Okay. So everything is fine. So I'm going to save this as video example 2 and then post it in Canvas. And again, if you want to turn into something new, it will ask you to save. Just make sure to save that time as well. Go to the new window. So that I stop this video.